Hey guys, welcome to your fourth independent study video. This is going to be page 19 in your notebook. And it should be one of the easier independent study videos you're doing for a while. 5.2 and 5.3 in your textbook are focusing just on polynomials, adding, subtracting, multiplying, and factoring them. So today we're just going to focus on adding and subtracting and multiplying them. So the first thing you can do is cross out the vocab at the top. We're not going to have to worry about that. I just want you to be able to apply that knowledge and be able to add and subtract polynomials and be able to multiply them. So it says in the examples to perform the indicated operation, and you have to simplify it as much as you can, if you can. So in number 1, I have two polynomials and I want the sum. So I am going to add like terms. So 2n squared plus n squared is 3n squared. Then I have a negative n and nothing else. And then a 5 plus 1, which is 6. So I am just adding like terms. Number 2 is very similar, except this time you're subtracting. And what I found is a lot of times people will remember to subtract the n squared, but they'll forget they also have to subtract that 1. So what I would recommend is changing it to an addition problem and then changing the signs of everything after in that parentheses. And then it's just a problem like number 1. 2n squared plus a negative n squared. Negative n plus 0, and then 5 plus a negative 1 is 4. So nothing too crazy yet. In example 3, it is still an addition problem, but before we can do that, we want to distribute. So that's going to be 6dm plus 2dn. Distribute once again, minus 5dm plus 20dn minus 10dm. So then I'm going to look for all of my like terms. I have dm's. 6 minus 5 is 1, minus 10 is negative 9. And then I have my dn's, 2 and 20 is 29. Oops, 29. Not even sure where that came from. 22. Now for the next 4 examples, we're going to be multiplying. Whenever you have two binomials, so like we do in number 4, you are going to FOIL. I'm sure your teachers taught this to you last year. But remember, it's first, outer, inner, last. So I'm going to multiply my 2 firsts, my 2 outers, my 2 inners, and my 2 lasts. Then all you have to do is combine like terms. So a binomial times a binomial, you're simply going to FOIL. Number 5, I have xy times x minus y squared. So you cannot distribute that exponent in there because I have a subtraction sign. So instead, what I'm going to do is instead of writing it as x minus y squared, I'm going to write it as x minus y times x minus y. Now it looks like it should be FOILed. First, outer, inner, last. And then I have to distribute that xy that's out front. And lastly, I need to combine those two like terms. So again, just adding, subtracting, and multiplying today. And number 6, I have a binomial times a trinomial. So I'm going to start by distributing just the t to everything. Then I'm going to do the same thing with my -3. Then it's a matter of just combining like terms. I have my 2t cubed, my 7t squared, my 5t, and my -6. Number 7, I'm still going to distribute each letter at a time. I just have more I have to distribute, with that one being 4 terms. So I'm going to leave myself some space here. So I'm going to multiply each one by x. To get my first 4 terms. Then I'm going to distribute my y to get my last 4 terms. And then we are very carefully going to combine like terms. So x cubed has nothing. I'm just going to highlight it so I know that it's gone. X squared y's. Switch the colors here. X squared y, x squared y. Those actually end up canceling out. X cubed y. xy squared, xy squared. So there's 2 of those. And then I have my last 2 terms, which cannot be simplified. So that's one that's not too difficult. I would just go kind of slow and steady with that one to make sure you don't make any mistakes with the exponents. But again, all of those 6 problems should have been a review, or excuse me, 7 problems should have been a review from last year. The little honors algebra 2 twist we're going to put on it is questions like number 8 and 9. It says, find the values of a, b, c, and d that make the equations true. So the first thing I'm going to do is change my subtraction problem into an addition problem by changing the signs of what's in the parentheses. And then if you look at the first 2 terms, you're not able to actually combine them because one has an a and one does not. But that a is what we're going to be solving for. So anything with an x cubed that I add on the left-hand side better equal the number of x cubes I have on the other side. So ax cubed minus 2x cubed better equal, and then I look over here on the right, and I do not have any x cubes. So that better equal 0. So the only thing I really need to worry about is my coefficients. A minus 2 has to equal 0. So in this case, if I add 2 to both sides, the a value would have to be 2. So we're going to go through that same process again, but this time with my x squareds. So I have a negative 3x squared plus cx squared better equal just 1x squared. The 1x squared came from the term on the right-hand side of my equal sign. So again, I only have to worry about my coefficients. So c in this case would have to be 4. Then I can look at my x terms and set up the same equation. My 2bx plus my 5x better equal 1x. Again, where did that 1x come from? It came from the right-hand side of the equal sign. Only worrying about my coefficients. And when I solve, I get b equals negative 2. And the last thing we have to worry about is just my constants, things that don't have any x's with them. So negative 2 plus 4d better equal negative 6. And I get d equals negative 1. Then we're going to go through and solve for a constant again, but in example number 9, you'll notice that it's multiplying. So the first thing I'm going to do is FOIL. Oops, 2 times 2 is 4. Then I'm just going to combine like terms to simplify that FOILed. Piece. And I have to remember that that has to equal the 6x squared minus kx minus 32. So if I go piece by piece, 6x squared, so no issues there. Kx, oops, copied that wrong. Positive kx, so those are the same. But if I look at this last piece, in order for that statement to be true, those two pink, my negative 2k squared, and my negative 32 better end up being the same number. And that's the equation I'm going to use to solve for k. I'm going to divide both sides by negative 2. Get rid of the square by square rooting. And remember, because it was my idea to take the square root, I have both a positive and a negative answer. And that is your value of k. If you have any questions on those 9 examples, I'd be happy to answer them either after notes, during class, or before or after school during some office hours. You just have to find me.